Alright, so the first thing we've got to talk about here is how to balance redox reactions. It's really not so bad once you get the steps down, but it seems like a lot if you've never done it before. So the way we do it is using the half reaction method. So what we want to do is split the equation into the oxidation half and the reduction half. So as I say down here, it's going to change a little bit, the method, depending on whether it's acidic or basic, but we'll get there. So looking at this equation, we have aluminum solid going to aluminum 3 plus on the product side and copper 2 plus on the reactants going to copper solid on the product side. So what's happening here is aluminum is losing electrons, therefore it's being oxidized, and copper is gaining electrons, therefore it is being reduced. So to balance this, the first thing you do is split it into the oxidation half and the reduction half, and that's what we've done here already. It's already split up for you. Then the first thing you do is you balance all the elements that are not hydrogen and oxygen. Then you would balance hydrogen and oxygen, which in this case there isn't any. And so the last thing you do is balance the charge. So what we do to balance the charge is we add electrons to make both sides of each reaction equal. So on the top one, the aluminum 3 plus needs 3 electrons on that side so that both the left side and the right side of the reaction they have a 0 charge. Then over here, we'll add 2 electrons. Now, to recombine them, we have to make sure the amount of electrons transferred are equal. So however many electrons the oxidation half gives, it's the same number the reduction takes. So what we would do is multiply the top by 2 and the bottom by 3 so that we end up with 3Al gives me, I'm sorry, not 3Al, 2Al, I'm getting ahead of myself here, gives me 2Al3 plus and 6 electrons. Then the bottom half is going to be 6 electrons plus 3 copper 2 plus gives 3 copper solid. So now the electrons given off are the same taken in, and you can just combine them. So we end up with the overall reaction of 2Al solid plus 3Cu2 plus gives me 2Al3 plus 3 copper solid. Just like that. So on this one, we have to go a little bit further, and it becomes more important that it's in acidic solution. So the iron goes from 2 to 3, so it lost electrons. So the oxidation part is iron 2 plus going to iron 3 plus. Balance everything. That's not hydrogen and oxygen, and then I just need to add 1 electron over here to make that work. For the reduction half, we have MnO4 going to Mn2 plus. So now the manganese is good, but the oxygen, to balance oxygen, I add waters. So I'm going to add 4 H2O. Now my oxygens are balanced, but I need to balance the hydrogen, so I'm going to add hydrogen as in H+. And since it's an acidic solution, it's totally fine to have H+. So now my hydrogens are balanced, my oxygens are balanced, my manganese is balanced. So now I just got to worry about the charge. And you see on the left side I have a total of +7. On the right side I have a total of +2. So I have to add 5 electrons over here. And now the charge will be equal. Except that I got to multiply this top one by 5. That way the amount given off is the same taken in. So now combine these, and we end up with 5 Fe2 plus 8 H plus NO4 minus. Then all these, I should have been writing my aqueous there. Right, and then on the product side, 5 Fe3 plus we go. And this is what it means by acidic solution. If it's acidic solution, it's okay to have this. But if it's a basic solution, it's not. So we have to do a little bit extra. So looking at a basic solution, we are going to start by saying, okay, well, the iodine is going from -1 to 0, so it is losing electrons. So the oxidation part, we have I- going to I2. So I need to balance that because it's not balanced yet, and then add 2 electrons. Then for the reduction part, just like before, I have my MnO4 minus going to MnO2, and my oxygens are not balanced, so I have to add 2 H2O to get the oxygens balanced. Now I have 4 oxygens on each side. I have to add 4 H+, but I can't have H+. So to neutralize that H+, I'm going to add hydroxide, enough hydroxide to neutralize it, make water out of it, but you have to add the same thing to both sides to keep it balanced. So with that, what ends up happening is these right here combine to make 4 waters. And so you got 4 waters on the left, 2 on the right, means 2 of them cancel. So the 2 on the right cancel, and you end up with 2 H2O on the left plus MnO4 minus gives MnO2 plus 4 OH minus. And now you have to balance the charge. So I got 4 minuses on the right, 1 on the left, so that means I need 3 more here. So to get these to match up, we'll multiply this by 2 and this by 3, and I'll end up with my final and that is the final answer. So hopefully that kind of helps make sense of everything. First thing you do, balance everything that's not hydrogen and oxygen. Second thing you do, balance the oxygens using water. Third thing, balance the hydrogens using H+. Then, if it's in basic solution and not acidic, you have to add that same number of hydroxides to both sides. Then you'll balance the charge. Then you'll make sure the electrons can cancel, however many given off by the oxidation is taken in by the reduction, and then just combine them. And that right here is your balanced equation. So sorry, this is a long video, but I hope it helps.